all yours.
All right, maybe if I can put my pointer. So today I was asked to give a tutorial on how to use GitHub. And there are many people in this center that are much more qualified to give this tutorial, but today this is going to be geared towards teaching really the bare bones basics to GitHub beginners. So what I did is I asked experimentalists around our lab about what would be the most helpful from a GitHub tutorial, and I tried to include that here today. So it may be a little bit boring for computational folks who are GitHub masters by now, but hopefully it's helpful for experimentalists or anyone here not yet super familiar with GitHub. And I won't be talking about Git itself, just GitHub. So what exactly is GitHub? It's the web interface, and really why do we care about using it? Well, GitHub is the web interface for Git, which is a distributed version control system, which allows multiple users at a time on a team to make their own changes to a program. And GitHub is really great to use because it allows for version control. It's a central location to keep all your code, and it's a really great collaboration platform. So as an outline for today's tutorial, first I'm going to talk about GitHub vocabulary. I'll go into the terms you hear when people talk about GitHub and what they mean. And then I'll tell you about how you can put content on GitHub and how you can get content from GitHub. And then I'll talk briefly about project insights and how to stay up to date with what's available on GitHub. So starting off with GitHub vocabulary, repositories are where you keep a project. You can think of it like a folder that contains all of your project files and their revision history. These can contain subfolders, images, files, videos, spreadsheets, and data sets, really anything your project is going to need. And this is what the inside of the Patent Labs Dubstep repository looks like. You have your content down here. You can see the title up here. A nice short description over on this right-hand side. And within a repository, there can be one or more branch. A branch is a workspace where you can make changes in a contained area within your repository, meaning you can make changes to a file in one branch and it will not affect the same file in other branches unless you tell it to. So what it is, it's a unique set of code with a unique name. Branches are a great place to test new ideas, to fix bugs, or to develop new features for your project. And the main branch, the one where all the changes eventually get merged back into, is called the master. This is the official working version of your project, and it's the one you would see when you visit your project repository at github.com/your project name. Within your repository, you can toggle between branches here. You can see that the Dubstep has a couple different branches here. Some more GitHub lingo. Whenever you're going to save a version of the file you're working on, you're committing changes. So this is adding, editing, or deleting files. This is all commits. Basically, any change you're going to make and save to your project is a commit. When you do this, you'll want to add a short description of your change here. So a little title here. And then it's also good practice to add a more detailed description here. And when you're committing this, you can make sure you can choose which branch to commit it to. See here, you can commit to the master or a different branch. So when you want to merge the changes you made in one branch into another branch, you submit what's called a pull request. You can then get feedback on your changes from your team, and you can discuss and review your code with your team before merging it into your main branch. So here I've shown you an open pull request on one of our Sigman Lab private repositories. You can see you can make comments here, and down below you can actually review the changes directly. GitHub will make a nice comparison using green and red to show what things have been deleted and added on the files that you're planning on merging. And so once you're ready to accept the pull request, you can merge the branches into your main branch or other branches. So here you see that the pull request that was open on my last slide has now been merged into my main branch. And after you merge, you can delete the branch if you would like to. So the workflow for updating your content might look something like this, or it might have multiple other branches that have been merged at various locations. But
you'd have your main or your master branch here. You might create a branch in your project where you can safely experiment and make changes. Here you're going to develop and test some new code maybe. You're adding commits along the way. You could then open a pull request and get feedback on your changes from people down the hall in your lab or across the world. You can then discuss and review your changes and then merge them into the master branch and deploy your code. So within a repository, you can also use issues to track ideas for your project and to report new tasks or bug fixes. So this is a good way you can assign individual issues to developers in your projects. So here I've shown an open issue that is just reminding us to add some data to this repo. And over on the right, you can see here, I could assign this to someone in my lab or on my team. And then once they complete that, you can close the issue. You can then review all the issues you've closed in the past to see kind of your project progress as you go. And so now that you know a little bit about the basic parts of GitHub, well, this is a tutorial, so let's look at how exactly you can put content on GitHub. Thankfully, the interface is really nice and it's pretty easy to follow, but the first step would be to make a repository. So first you're going to log into GitHub and then click on the repositories tab and then click new over here. This is the screen that will then pop up. And here you need to name your repository. You should pick a name that's unique and perhaps descriptive, or make it fun, whatever is your style. You can choose to make it public so that the whole internet can see this repository, or you could choose to make it private, meaning you can choose which users can see and commit to this repository. And optionally, you can add files like a README or a license right off the bat here. So next, you need to add content to your repo. You can go to your repository and then you click Add File right here. And you can either, if you do create new file, you can make this file within the GitHub interface on the web, or you can click Upload Files, which will bring up a screen that looks like this. And either way, you'll see when you're going to commit your file, you'll want to add your short title here, what you're doing. So maybe you're adding files. And then here you can see I've written a description about what this file update has done. And here you can also commit to the appropriate branch. So some things you should consider including in your repository could be an example input and output, comments on your commit. So like I said, what are you uploading or updating with this commit? You should always have a comprehensive README describing what your code is and how to use it. And then depending on if it's public or if it's appropriate or not, you should consider adding a license to your repository. The MIT license is often appropriate for what we do in C-CAS, but if you're unsure of what license to choose, there's a handy website called choosealicense.com that will kind of take you through a flow chart and tell you the pros and cons of each license. So you now know how to put content on GitHub. And how do you get code off of GitHub? If you find someone's repository that you think would be useful for you, well, if you're comfortable with Git or Git Bash, you can use git clone. You type git clone and then the URL to the repository. Or you can just download directly from their web interface. So you go to the repository, and you hit this drop down menu, and you can hit download zip here. And this will download directly to whatever is your designated downloads folder. And then you can unzip and move it to your desired location. So that's pretty easy to get code off of GitHub. So let's talk a bit about project insights. So on the Insights tab of your repository, GitHub provides statistics and tracking history in order to give you insight on your project's progress, as well as its popularity and use. For instance, in this tab, you can see how many pull requests and issues have been opened and closed.
You can also see who contributed to the project and when, and you can view the flowchart style representation of when different branches were created and merged. Of course, we also like to see how popular our code is and how people are using it. This can be really helpful for your project itself. And so here's one metric you could look at. This is just a plot of the number of people who have cloned your repository, though this is only clones using git clone, it doesn't show any downloads when you download the zip file. And then on the bottom here, you can see the number of people who have visited your repository. And depending on who your users are, maybe this is a more appropriate metric for you. I know in the Sigman lab, most of us do download zips. So you can see this repository only has 5 unique cloners, but I do know that it's probably close to 20 of us in our lab who have cloned this or have downloaded it. And so this is probably more representative of that. So additionally, when you're on your project repository, you can look up in this top right corner. First thing you can look at is how many people are watching your repository. So if you watch a repository, you're going to get notifications about changes that have been made. You can also see who has starred your repository. People star repositories for several different reasons. They can just do it because they like it or to show you that they like it. Some people use it as like a way to save repositories that they like. There's no hard and fast rule there, but it's a good metric to see. And on the far right is one that I'm always really interested in, is to see the forks. So a brief aside about what a fork is. A fork is a copy of a repository that you manage. So within your fork, you can make changes to the project and it won't affect the original repository. If the original repository gets an update, you can fetch that update into your fork so that your fork stays up to date with any of that. And if you want, you can always submit a pull request if you feel like your changes in your fork would be beneficial for the owner's central repository. Excuse me. In the Sigman lab, we really like to look at forks because you can see if someone saw your code and thought that they could improve it in some way. So I like to go look at that code specifically to see what people have done and if we should be potentially merging that into our branch. It's a good way to get the wheels turning about how to make your project better sometimes. And so with all of the changes that can be made in GitHub, how do we make sure that we are up to date on the projects we use or that we might want to follow on GitHub? One way you can get updates is you can get them sent to you on Slack. So you can go to this website to add the Slack or the GitHub app to Slack, and then use / commands to control it. So the first thing you do is you want to link your Slack and GitHub accounts, just / GitHub sign in. And then you can subscribe to repositories. So / GitHub subscribe, and then the link to that repository. You can see here I did this for our threshold repository. And now the channel that I did that in will send a Slack every time someone makes a new commit to that repository. This is something our group uses a lot so that we can make sure we are all using the most current version of our modeling scripts, for example. We found this really helpful. There are different things you can do with these / commands. So if you want to learn more about this, I would recommend this website. Furthermore, for staying up to date, you can go to a repository and you can watch it, like I mentioned before. You can choose what kind of notifications you'll get, but if you're really interested, you could just get a notification for any kind of activity on this repository. You could also follow an account by clicking this button on their profile. And this is another good way to see, if you like the things the Patent Lab is putting out and you want to be updated on when they create a new project, you could go follow their accounts here. So I went through that pretty fast, and I'm happy to answer any questions we have, but I hope that what I gave today was a bit of a beginner's guide to what exactly GitHub is and how you can use it. It's something the center, we have a C-CAS GitHub
account that we have some linked repositories to that is great to check out if anyone's interested. Yeah, I'm happy to take any questions.
All right, thanks, Ellie. With that, the discussion is open.
I have just one comment. I know these popularity graphs where you check, the number of clicks and number of comments, and I know it's a long-standing issue because those are only available for 2 weeks or last 15 days. And I think we've been asked numerous times about like popularity of our GitHub repositories, and then it's volatile, so you can't really get the longer history. And I think there are various tools to kind of keep tracking this, making sure that you take a snapshot every 2 weeks to make this history longer. I have no idea why GitHub has organized it this way, but it's been like that forever and has never changed.
Yeah, it would definitely be nice if you could just have a full history.
I mean, yeah, you don't have to ask me. Yeah, I know.
Alternatively, I can ask Katie to track these things. Any other questions?
How are you guys sort of managing what's private and what's public? You sort of, like, you showed some private repos today, and the threshold is public. So I guess I asked, there was something that came up with the C-CAS one recently with the Notre Dame folks. We put out a CSV, and apparently it had some IDs about the people in AstraZeneca who'd actually run the reactions. And we deleted it, but obviously one of the joys of GitHub is that you never actually delete anything. So it was still there for a bit. Hopefully it's gone now, but I just wondered how you guys are managing all that side of things.
We are personally pretty stingy about what we make public. That's largely because none of us are very good at coding, and so it's all a little bit too ugly to share with the public often. We're working on getting it more, cleaned up so that we can share more of this and, have it truly be open source and shared with everyone. But we also use it to just organize our in-house scripts. In the past, we used a Dropbox for a while, and that just turned out to be a bad way because people wouldn't update things on time, or people missed when we made updates. And this was just a good way for us to, if we have in-house scripts that we're working on but not ready to send out to the public, we can all at least make sure we have the same version. We also have a system or a rule where we label all of our scripts with version numbers in addition to the versions that GitHub assigns it, largely just for ease of use. But that way then within our subgroup presentations and our progress reports, we have to write down what version script we use. So the title has that version in it. And then we can ask people, if they're behind on the versions, why they're not using up to date, or, understanding the differences there.
And honestly, anyone in C-CAS who wants access to our private scripts can have it at this stage. I mean, unless they're in really early development. But we just hired a person starting last Friday who is a CS major to help us clean up our scripts because we want to put all of these out publicly, but we've had just way too many cooks in the kitchen. And if you looked at the ensemble of the table, has been absolutely horrendous. And I'm not a coder, as you guys all know, but from what I have been told and have seen even myself, we're getting close to fixing a lot of our kind of standard scripting.
And
one thing that we ran into, it's just a sort of a word of warning related to Rob's question about public versus private, is at some point we had sort of this plan of, everything was private until paper was published, and then we made it public. But the link actually changes between when the public private. And so when the draft that was reviewed had a private link, and that was approved, and we accepted the proof we switched it to public, and then all of a sudden you need to make a correction for the paper because the link changes between public and private. So just a quick note to, at least, yeah, in our experience that happened. So be aware of that if you're thinking about doing that sort of public-private switch when you do it.
That's good to know. The other thing that I don't know, why we're a little bit stingy about when we make things public, like you do, we often make it public once a paper is published. But once you make things public, people can ask you questions about it, which is great, but it can also, right, if people don't know exactly what they should be using it for, can create more work for your team. And so that's one reason we are often a little bit stingy there too.
All right, if there's no other questions,